So, hello everyone, my name's Chris Jenkins. I'm a developer advocate for Confluent, which means I spend most of my time building stuff with Kafka and talking about it in one form or another. And the idea for this talk comes from a company I co-founded years ago. We used to sell gold and silver online. We were a startup in the early days. And one day, one quiet afternoon, I think it was a Friday lunchtime or something, I decided we've got a startup. We're actually starting to sell things to customers. It's actually starting to work. I'd like to see how much money we're making, how much stuff we're selling, and watch that tiny number gradually, hopefully grow as the business grows. So I threw together, it was a real rough hack of a dashboard, which amounted to little more than an SQL query spitting out HTML. The only good thing you can say for it is it worked and it was quick to build. But if you went to this web page and hit refresh, then it would chew through all the data and give you updated sales figures. And you could share this URL around the company and people would mash refresh and occasionally see how the business was doing. As you can probably imagine, after a few years and several million rows of data, this started to really creak. And I'd always wished we'd had the time and bandwidth to go back and engineer it properly. But we never did. So this talk is kind of for past me and hopefully for future you. We're going to build from scratch a live streaming dashboard of sales figures. So to prove it's from scratch, here's an empty directory. Completely empty, nothing up my sleeve. And let's imagine that we've got a business that's selling stuff. And the data of each sale goes into a Kafka database. So if I log into KSQL, so I can run queries against my database, and let's see, if I say select star from purchases, and we'll just watch that live. And we should every few seconds in this simulated business be getting another sale of some random price. This is dummy data, but it could easily be real data in a real organization. What I'd like to do is turn that into a live dashboard, and I've got about 20-25 minutes to do it. So let's get started. The first thing I'm going to do is I am going to create a React app. And the reason I'm doing this first is it takes ages to run. So I'm going to leave this running in the background. Okay. So the real first thing I'm going to do is start by looking at that data and rolling it up into a summary. So I've got this stream of purchases, and I'm going to say, let's create a summary table. I'll call it dashboard, and I'm going to create it as a select statement. Select sum of the price of the thing sold as a total from purchases. And if you know your SQL, you know that I just need to group by something. What am I going to group by? I don't really have a natural grouping key here. So I'm just going to create an artificial one. I'm going to say group by sales and create a fake column called sales as category. That little bit of SQL should roll up the stream of purchases for me. Let's just check that. Select star from dashboard and we will watch it live. And now every time a purchase goes in, this table gets updated, and within this query we see the updated value. So the amount we've sold is gradually creeping up. And that's about all we need for the database tier. That should do it. So I'm going to move on to the Python server tier. And I'm going to say, let's start with the virtual env for hygiene. I have no imaginative name for it, so I'll just call it env. And I know there are a few libraries I'm going to need, so I might as well install those now. I know I want the Confluent Kafka library, so I can actually connect to Kafka. I would like a Websocket server, so I can stream this to the front end. And I know I'm going to need to do some JSON wrangling, so I'm going to put in simple JSON as well. Now we see how well my internet connection can cope. There we go. Okay. That should do it. So, let's edit my server file and write some Python. Go. There we go. Right, standard preamble. How are we going to write this? Well, unsurprisingly, I'm going to have a main function. And I'm just going to set it running. And at some point, I know I'm going to start a database connection. And at some point, I'm going to start a web server. There. So, yeah, that should do it. Let's start with this database connection. So, run database consumer. And I will stick that here. And what the database consumer is going to do is connect to my database and watch that dashboard table we just created and deal with the new changes as they come in live. So how to connect to Kafka? Well, in Kafka parlance, what I need is a consumer. Could be called a reader. It's not called a reader, it's called a consumer. Same idea. And the latest recommended type of consumer is a deserializing consumer. There have been other versions in previous versions of the library, but we don't really need to worry about that. And let's see, just import Confluent Kafka, and that should let me there we go. Oh, there's a typo. Deserializing is one of those funny words. It's hard to spell sometimes. So, I'm going to need a configuration. I know that. I'm going to worry about that a bit later. Once you've created a consumer object, you need to tell it which database tables or streams of data to listen out for. So I'm going to subscribe to a list with only one table in the dashboard. Once you've done that, you can go into an infinite loop and say, let's see if there are any new messages to deal with. So poll every 200 milliseconds, that should be fine. And we'll get a message, and then we're going to deal with that message here. So I've got to figure out the config, and I've got to figure out the message processing. Let's start with the message processing. Incidentally, if you have questions, stick them in the chat. That's probably the best way for us to field those, but feel free to do it at any time. So how do you deal with a message that comes back from that consumer? Well, it can be one of three things. The simplest thing it can be is none. There might not be a new message to deal with. If that happens, I'm not going to do anything fancy. I'm just going to print waiting to the screen. It might, and we've got to handle this, it might be an error. Hopefully not, but it might be. And again, I'm not going to do anything fancy with it in this demo. I'm just going to say, let's print that to the screen. But hopefully, most of the time, it's an actual message value. And we can just pull the value out. And again, for now, we'll just print it to the screen. So that is a Kafka database consumer. We just have to worry about configuring it, and hopefully we'll have our beginner's guide to talking to Kafka from Python. So how do you configure it? Like nearly all database drivers in the world, the first thing you do is tell it where to find the server. And for that, it's a configuration called bootstrap servers, which is a funny name for it until you realize that Kafka is kind of built from the ground up to be sharded, partitioned, clustered, horizontally scaled. So instead of connecting directly to the database, you connect to someone which will tell you where the data can be found, and you just let it worry about exactly how things are routed from there on in. So I have mine running locally on localhost 1992. That's what I need to do for that. The second configuration parameter I need is a group ID. And again, because in Kafka things are kind of built from the ground up to be distributed, scalable horizontally in different ways, one of the nice features it has is you can connect several processes with the same group ID, and then the database will automatically share out new messages among those consumers, which can be a great scaling feature, but it's outside of the scope of what we're doing here. So literally any unique ID will do here, so I'm going to go for a UUID. And that will be fine. Oh, yep, let's import that. And then the last parameter I need is I need to tell the database deserializing consumer how to actually do that deserialization. So I need to define a value deserializer. And I'm going to just define that outside of this code. It's deserializer. So let's define that here. How do you deserialize values? Well, when we create the table, by default, that was created with an automatic schema. And schemas by default in Kafka are encoded as Avro. And if you haven't heard of Avro, it's a lot like Google Protocol buffers, which is also an option, and JSON schema. It's just a way of recording the structure of each row in that table. So I can create an Avro deserializer and tell it how to connect to the database to get that schema information by pointing it to my schema registry. And if I do that correctly, then everything will magically deserialize and the bytes coming across the wire will turn into Python data structures. So the last part I need is to define a schema registry client. And this is boilerplate stuff that you can kind of do on Rails after a while. Like all database connection, driver, configuration things. A schema registry client takes one parameter, so I'll just define it in line. It needs to be a URL, and the URL is where you can find that server. And in my case, I've got it running locally on port 8081. So with that, I have configured a database connection. I've subscribed to my new table that I created earlier, and I'm looking out for new messages. So with a bit of luck, should we see if this works first time? No module named Confluent Kafka. That is because I forgot to source my env. Slap my wrists. Oh, no. Let's just see. Okay. I know what it is. I didn't source my environment before I did pip install. Live coding. It's always fun. So let's do that again. And I should have hold music for these moments. I'm going to need to do my WebSockets again, aren't I? And simple JSON. I'm going to need all three of those. Okay, my virtual environment now has that data. So hopefully, start database connection. There we go. We're streaming data in Python. So if you ever want to connect to Kafka with Python, that's the bare bones of how it's done. So what's the next step? There are two things I want to change about this. The first is I'm going to want that total decimal thing to actually be JSON. So let's start there and say that the formatted version of this is just using simple JSON's dumped string function. And yeah. Import that, and I'll just change this value to the formatted one. And the other thing I'd like to change is this is kind of ugly. Now, for time, I'm going to be a little bit lax on cleaning up all my resources in this, but I think I will just tidy that up and say, let's install a signal handler. Whenever you get an interrupt signal, just give it the default handler, and that should clean that up. So I should be streaming JSON objects, yes, and if I kill it off, it kills really reasonably cleanly. So that's the database part. Time to start thinking about a web server. I'm just going to check if there are any questions at this point, just as we have a brief pause. No? Good. Okay. I'm assuming that means everyone's following along with me. Sometimes tough to tell on these online things, but we'll keep going. So, how do I build a server? Well, the right choice, as I've kind of hinted already, is a WebSocket server, because I want to stream this data live. I don't want to be manually refreshing. I think it's much more satisfying if this is a WebSockets thing. So, I am going to start up a WebSockets server with the serve function, which takes 3 parameters. First is a function which handles each connection as it comes in. Second is the host to bind to, and the third is the port. Let's import WebSockets. And I'm going to need to define that. Oh, was that a question? Does look straightforward. Good. So, I need to define a connection, and I will tell you now that the handler takes 2 arguments. It takes the WebSocket the individual user is connecting on, and the path if they've requested one. The thing that makes this slightly more complicated is we need to start thinking not in blocking functions, but asynchronous ones. So, let's convert this to some async code. That needs to be an asynchronous function. This we need to wait on. Main is going to have to be asynchronous, and we are going to have to invoke it differently with async.io run. And this isn't in any way going to be a full tutorial on async.io, but it is going to be a recipe. So maybe you can, if you've not used it before, you can walk away with that much. And the last thing is, this is a blocking function, and it's not really async friendly yet. So what I'm going to do, instead of making it async friendly, is I'm going to fork it off to its own thread, which I can do with get event loop, and then tell the event loop to run in an executor. Default thread pool, this is the function I would like you to run, and that will then fork my database connection code off and worry about the WebSocket server. Let's just import that. There. So hopefully, so before we go ahead and test that, let's actually make the WebSocket connection do something. Let's just say, when the user connects, we will say send them hello world, because we're desperately original. That should do it. So let's test that. Start my server running again. Still connecting to the database happily. Now, I don't know if you know about this, but there's a really useful tool if you're dealing with WebSockets, just called WS, and it's like the telnet, the netcat of connecting to WebSockets. So if you ever work with WebSockets, I would thoroughly recommend putting this in your toolbox. And I can just say that. And hopefully, yeah, so it connects, we get the hello world message, and it closes. That's a slight problem. I don't want it to close. I kind of want it to stay open indefinitely. So there are a few ways to do that. I'm going to do it this way. I'm just going to block on a future that never gets filled, and that will just hold this asynchronous bit of code open, which holds the WebSocket open. Okay, so I have a bare bones WebSocket server. Let's turn it into a data streaming WebSocket server. How do I do that? Well, this is something I actually really like about this code in Python. The WebSocket server makes it really easy to do broadcast connections. A lot of languages and a lot of libraries don't let you broadcast messages to all your WebSocket connections at once without a lot of pain. But this is really taken care of in the Python WebSockets code. And I can just say websockets.broadcast. I need to tell it who to broadcast to, so list, set, iterable of clients, and then I can just send it that formatted JSON. Where am I going to get my set of clients from? Not in this code. So let's pass it through as an argument. And in order to pass it through as an argument to the thread, when you're running in an executor, you have to do it like this. Then I need to initialize my clients. I'll just use a set. Set seems like the right choice here. And then what I'd ideally like to do is pass those clients to handle connection and come in here and deal with the clients here. But I can't do that because that's not the right API for WebSocket Serve. It's expecting a 2-argument function. So how do I send out? And again, this is the thing where there are a couple of ways to solve it. I could define a function that takes the clients and return a new function. And in a way, that's what I'm going to do. I'm just going to do it with library code. I'm going to say, I'm going to import partial from functools, and that will happily, for me, turn this 3-argument function into a 2-argument function by binding the first in kind of bit of higher order function magic. So I get to write my code as though it takes 3 arguments, but I'm really binding the first argument here, and then WebSocket Serve is dealing with the remaining 2. So with that, if I jump over here, I should be able to say clients.add this WebSocket. Now when a client connects, we add the WebSocket to the set of clients, and when a message comes through from the database, we broadcast to that newly added client. So let's see if that works. Let's run that server. And if I connect, hopefully I'm going to see hello world and then the live data as it streams through. Hooray! That's almost it for the Python code. I'm just going to make 2 changes, I think. The first is I don't really want to have to deal with a mixture of hello world and JSON, so I'm going to delete that. And the second is I've got a slight concurrency problem, which is I'm reading from clients here on this thread, I'm writing to it here on this separate thread, or this async block, but set isn't thread safe. There are a few solutions to that, but I'm going to go with a simple one. I'm just going to say, let's take a lock from threading and import that. And I'm going to pass that lock around anywhere I pass clients around. So put the lock here and put it here as well. So yeah, everyone that gets clients now also gets a lock, and then I can just go to everywhere I'm using clients and say with that lock. So that's going to block out other readers and other writers. So we get exclusive use to this set, we mutate it with a guarantee that no one else is touching it, and now this code should be pretty thread safe. I've not discovered any bugs in it yet. Famous last words. So that, I think, does it for the Python code. Let's just test. No hello world, but we are getting messages. And let's just check it's a real WebSocket server. Let's connect another client, and they should both get the same messages live at the same time. Okay, let's leave that running. It's a Python talk. I could stop there, but it wouldn't really be satisfying. Let's just build a quick client, which hopefully has finished building. So if you remember, we did npx create react app client, and that created this. Let's start it running. And while that starts running, I'm going to edit source app.js. We are now in the world of JavaScript. I'm sorry if you're of a nervous disposition and this scares you, but we should be good. There we go. Let's just allow that. And with a bit of luck, can someone just confirm you can see this browser tab? Anyone, please? Yep, cool. Okay, thank you. So that is a base React app. Let's make it speak WebSockets, and we'll finish this dashboard off. I'll take out this React link. So the way React works, to give you a very fast overview, is it's not too dissimilar from the summary table we created, actually. Messages come in somehow, and every time the message comes in, we update some internal state in our React app, and then we define how that new state should be rendered out to the screen. And as long as we do that, the rest is taken care of magically. So if you're all, I'm guessing most of a Python group is mostly back-end developers. If you ever wanted to get your feet wet with the front end, well, you'll find this actually isn't that scary. So I want to run a WebSocket, connect to the server. So let's start by defining where to find my server. It's at localhost 8080. That's my WebSocket URL. And then I am going to say, let's put that WebSocket as part of this server's state. To do that, I use a React function called useState, which lets me manage a piece of state. And I will call it with a new WebSocket with that URL. And useState returns a pair of things. The first is a reference to that WebSocket that's been created, and the second is a special setter function that lets me update it if I need to. I don't think I'm going to end up using that, but you get that. And let's import that. Import useState from React. Okay, so what next? There's also another function a bit like useState, which is called useEffect, and lets you define code that will have side effects. And we're dealing here with the side effect of reading external data. So I'm going to use that, and I'm going to say useEffect. Install this handler for me. Take the WebSocket and define what it should do whenever it gets a message. And that is a function that gets some let's say message. It takes a message and we do something with it. Let's just for now log it to the screen. And that should do it. Yeah, that's right. Is that right? No, I'm just mislining our brackets. There we go. So if I run that and have a look in the console, make that a touch larger with a bit of luck. Yeah, it's already automatically reloaded and we are getting messages through from the Python server. And the stuff we want is inside this data thing. So let's say message.data. In fact, let's say our value is message.data. And that's a string, so we're going to need to parse that JSON string. So let's say JSON parse that message data. And then hopefully, if I do something like value total in the console, yeah, so that's printing out that value. We are very nearly there. Final straight. We need to use another piece of state. And the state we're going to use is going to be a message. And we'll start out with the message waiting. And that identically is going to give us two things, a reference to the message and a setter. And then all we need to do is in here, we say set message to value total to, let's format it nicely. Let's convert it to a localized string. Okay. And then we just change this to print out the message. And I think that should do it. That's our live streaming dashboard in maybe a shade more than 25 minutes, but certainly in less than a lunchtime's worth of hacking. Let's just make this a bit bigger for fun and put a dollar sign in. There we go. That's my fledgling business's live streaming dashboard of sales end to end.